When a physical object decays, when a building collapses, or a stone turns to dust, we experience it as a permanent subtraction. We assume the information that defined its structure is gone. But there is a question of whether that data has truly been destroyed or merely slipped beneath the surface of what we can see. The standard mechanistic view of physics treats this physical decay as a final erasure. When a system loses its structural coherence, its historical data is treated like a liked hard drive. The ODTOE framework approaches this differently. It proposes that our observable physical universe is not the base layer of reality, but rather a secondary projection. Under this model, reality is split into two distinct, parallel registers. The first is the classical observable world. This is the physical domain we inhabit, where things appear, age, and eventually vanish from our sight. The second register sits beneath that physical plane. It is a mathematical domain known as the Hilbert space of potential, a structure existing outside of time where information is permanently housed. If a mathematical layer serves as the true foundation of reality, then physical decay is an illusion caused by a limited perspective. The object is gone, but its information remains. In the late 20th century, philosopher A.F. Losev established the concept of the Hyletic number, defining it as the primary matter of meaning. Ordinary arithmetic numbers are instantaneous snapshots of a single value. A Hyletic number carries a permanent, associative, holographic memory of every state it has ever held. The ODTOE framework takes Losev's philosophy and formalizes it through a specific mathematical operation known as the mu-L mapping. This mapping translates a Hyletic number directly from the classical world and anchors it as a permanent coordinate deep within the Hilbert space. The present moment is never an isolated dot. It is physically tethered to an unbroken historical trace of its past. This structural concept traces back to the 1890s, when mathematician Nikolai Bugaev conceptualized open monads. These were defined as centers of action that continuously receive and perpetually store information. By formalizing this, the mu-L mapping functions as a cosmic ledger. Regardless of physical destruction on the surface, every event is indelibly written into the architecture of potential space. This raises a structural question. What actually happens within this framework when an object undergoes decoherence, or when observers lose focus on it? In the classical world, the effect is immediate. The projection simply blinks out of existence, simulating total physical destruction. The paper counters this apparent disappearance with a central mathematical proof, Theorem V, also known as the weak indestructibility theorem. The theorem's first finding establishes that losing the classical projection does not remove the underlying entity from the Hilbert space. Looking at the equation, we see that the mathematical norm is strictly conserved. Even as the physical projection drops to zero, the total information value survives completely intact. However, this indestructibility is classified as weak. The information is preserved, but it is not automatically retrievable under just any conditions. Retrieval requires reaching a specific threshold, called S-rec. This is the minimum operational level of pairwise coherence that a cluster of observers must achieve to pull that state back into the physical world. Information is never erased, but accessing it requires observers to precisely tune their collective focus back into the specific frequency where that data is held. Recognizing that memory is permanently archived forces a reevaluation of how cause and effect move through time. Systems are not just pushed forward blindly by past causes. The framework incorporates teleological causation, the principle that systems are actively pulled toward future goals. These final goals operate as mathematical fixed points, known as Banach attractors. They draw the evolutionary state of a system forward, guiding it toward a stable configuration. This creates a geometric paradox. How can the underlying architecture store an infinite accumulation of historical holograms without running out of dimensional room? The solution involves Kudrin's mirror sphere, connected by the Adele bridge. As you push past the exterior, an infinitely nested fractal architecture reveals itself. This specific topology has a finite external volume, but through a mathematical property called p-adic nesting, it becomes infinitely roomy on the inside. The universe functions as an associative hologram. The past is not burned as fuel to create the future. It is archived within the geometry of reality. waiting for us to look closely enough to see it.